You know what? Every crime scene, there's a silent witness. A signature left behind by a suspect, often completely invisible. Today, we're cracking open the case file on one of the most powerful tools in all of forensic science.
It all comes down to this one simple, powerful idea. It's actually called Locard's exchange principle, and it's the absolute cornerstone of forensic investigation. Basically, it means that every single time you touch something, you leave a tiny part of yourself behind, and you take a tiny part of it with you. It's like this invisible thread that connects a person to a place.
And that's the big question, right? How on earth do you read a clue that you literally can't even see? Well, let's find out. Welcome to This Explainer from Smart Tutor, where today we're dusting for prints.
All right, to solve this puzzle, our investigation has to start at the very beginning, understanding what exactly makes up this invisible calling card.
So what is a fingerprint, really? It's not just the cool pattern of lines we see. On a scientific level, it's an impression left by what are called friction ridges on our skin. That's just the fancy term for the raised parts of our fingertips. And here's the secret sauce. These ridges are covered in tiny pores that are constantly giving off a little bit of perspiration. It's that moisture, this unique little cocktail of sweat, oils, and salts that gets left behind on a surface, creating a perfect, though often invisible, copy of that pattern.
And that pattern is your unique signature. I mean, truly unique. It's formed by a totally random process when you're in the womb. Things like pressure, how you move, it all plays a part. That's why in the entire history of collecting fingerprints, no two have ever been found to be exactly alike, not even on identical twins. No way. This incredible uniqueness is exactly why fingerprints have been such a game changer for law enforcement for more than 100 years. Okay, so we know this totally unique signature gets left behind. But here's the catch. Most of the time, it's what's called a latent print, which just means it's completely invisible to the naked eye. So the question is, how do investigators make this crucial clue appear? Almost like magic. Well, it's a really meticulous process, as you can imagine. It all starts with an exhaustive search. Investigators have to put themselves in the perpetrator's shoes. Where would they have touched? A doorknob? A glass? A weapon? Then comes the development stage, where a little bit of chemistry works its magic to make the invisible visible. And the final steps are all about carefully collecting and preserving that print so it's ready for the lab. But here's where it gets really cool. It's not a one-size-fits-all kind of deal. The detective's toolkit is super specialized because the surface you're working with totally changes the chemical you need to use. For something non-porous, like a plastic gun, they might use something called cyanoacrylate fuming. I mean, that's basically superglue vapor, which reacts with the print and turns it white. If a print is left in blood, they'll use amida black, which reacts with the proteins in the blood. And what about the sticky side of duct tape? For that, you need a special powder that actually clings to the skin cells and fats that get left behind. Okay, so we've successfully lifted a print from the scene. Now we get to the most critical part of the whole investigation, the actual science of identification. This whole thing, the entire science of identification, it all hinges on this one super powerful principle we talked about earlier. Not only is every single person's pattern of friction ridges unique, but unless you get a really deep scar, it stays the exact same from the day you're born until the day you die. So that really begs the question, doesn't it? We know they're unique, but what makes them unique? When an examiner is comparing two prints, side by side, what specific little features are they looking for to be able to say with confidence, yep, that's a match? Well, examiners break it down into 3 levels of detail. Think of it like zooming in. Level 1 is the big picture, the overall pattern. Is it a loop, a whorl, or an arch? That's just for general classification. To actually get an ID, they have to zoom in to level 2 and analyze what are called minutiae. These are specific points like a ridge ending, where a ridge just stops, or a bifurcation, which is where one ridge splits into 2. And finally, if they have a really clear print, they can zoom in even further to level 3 details, the unique shape and edges of a single ridge, and even the exact placement of individual sweat pores. But you know, while fingerprints are famous for solving crimes, their story doesn't end at the crime scene tape. Not even close. I mean, how many of you unlocked your phone with your fingerprint just today, right? That's biometric security in action. This technology is everywhere now, from letting us into secure areas to conducting background checks for sensitive jobs. It also has this incredibly important humanitarian use, like helping to identify victims of major disasters or patients who have amnesia, which can bring answers and closure to their families. But, like any good detective story,
there's always a twist. No piece of evidence is perfect, so it's time to look at the fine print in this case file, the unseen limitations of fingerprint analysis. And here's the crucial thing to remember. While the print itself is pure science, the person analyzing it is human. And we humans can be affected by things like fatigue, pressure, and even bias. Just think about the pressure that comes from, say, overzealous investigators who know they have the right guy. That kind of outside influence can be a huge challenge to a truly objective analysis. And it is so important that we're clear about what a fingerprint can't tell us. It can't tell you when it was left. It could have been an hour ago or a week ago. It doesn't tell you anything about the age, sex, or race of the person who left it. And maybe most importantly, it provides zero context. Think about it. A person's fingerprint on a kitchen knife could mean they're the killer, or it could just mean they helped make dinner there the night before. The print is a clue, but it is not the whole story. And that really brings us to the heart of the matter for this whole investigation. The physical print itself provides the scientific clue, sure, but it's a human examiner who provides the final conclusion. It really makes you think. In the world of forensics, where does the hard science actually end, and where does expert judgment begin? And on that thought, we're going to close this case file. A huge thank you for joining us on this investigation. Your support is what makes it possible for us to do these deep dives.
We really hope this explainer made the invisible world of fingerprints just a little more visible for you. If you found it interesting, do us a favor and hit that like button, and definitely subscribe to the Smart Tutor channel so you don't miss the next case file we crack open. Thanks for watching.